Dear students, today I am going to explain about inductive bias. This is the last topic in the first module. Already we have discussed about from introduction, then designing a learning system, and then we have seen the concept learning as a task and search, and then after that we have seen finders algorithm, candidate elimination algorithm, version space. Now we are going to discuss about inductive bias. So the fundamental questions for inductive inferences are: what if the target concept is not contained in hypothesis space? So we already told initially we'll take that end of complete thing as within a hypothesis space. Then for each training example we are going to check the consistency. If it is consistent, we'll keep it. Otherwise we are going to eliminate it. That's why list then eliminate algorithm we have seen over there. But if the target concept is not contained in hypothesis space, means what is the problem? Can we avoid this difficulty by using hypothesis space that includes every possible hypothesis? That is also problem. So we can't include all the hypotheses. Possible hypothesis. We'll see the example, then you people can understand. So how does the size of this hypothesis space influence the ability of the algorithm to generalize to unobserved instances? Okay, so observed, by seeing that known instances we can define. Unobserved instances, how we can how the size of this hypothesis space influence the ability of the algorithm. We'll see that. First, okay, how does the size of the hypothesis space influence the number of training examples that must be observed? Okay, that everywhere the training examples and testing examples are important. Okay, number of training examples may matter. Okay. In machine learning, the term inductive bias refers to a set of assumptions made by the learning algorithm in order to perform induction. Okay, so that is to generalize finite set of observation into a general model of the domain. Okay, so using that inductive bias only we are using. So finally we want to make a general model for the domain. Okay, any domain will take general model, we want to make it with the training data. That is the main thing. That this one as a set of assumptions can be made either implicitly or it may be explicitly. Okay, so for this we'll see the previous example only. In that, for example, so we'll have one is sky may take sunny or cloudy value. We already told. So in this case, for example, first one is positive training example. Second one is positive. In that both the things, sunny, that wind may be, the sky may be sunny or cloudy. The person can enjoy the water sport game. It is there. So in that case, sunny or cloudy, it can take any value, either sunny or cloudy. So we'll make it as a question mark in general. Next is warm specific. Next is normal specific, strong, cool, change. Remaining all are specific value. First one we are making it as a general. But then a person can go and play. That means what hypothesis we are going to get? Question mark, warm, normal, strong, cool, change means person can enjoy the water sport game. Okay, and suppose for example in future we are getting another data set. Okay, instance, that is rainy, warm, normal, strong, cool, change. That is in that case person can't enjoy the water sport game, negative. Okay, so now also rainy is there. So that is rainy. Then in general, first attribute we are given question mark. That question mark indicates it can take any value. It can take sunny, or it can take cloudy, or it can take rainy. Okay, but now negative also it is included over there. Remaining attributes same value. So now there is no way to differentiate positive and negative training examples. Both has the same hypothesis. Okay, so this is the problem. This is called as inductive bias. So that is the thing. After first two training examples we are getting this, but that hypothesis overly generally it covers the third negative training example also. That also it covers. Okay, so incomplete hypothesis spaces, if C not in H, then consider generalizing representation of H to contain C, general only, like the previous one. So the hypothesis instance space x of days described by 6 variable attribute is 96. Okay, the number of distinct subsets that can be defined over the set X containing modulus of X elements, number of elements. That is a power set of X, that is 2 power modulus of X. Okay, so there are 96 instances in the N-choice sports. There are 2 power 96 possible hypotheses in full space. So everything we should take, then only we'll get the correct hypothesis, target function. Okay, so this here we can use incomplete hypothesis, we can use and or not. So here we'll see there positive examples x1, x2, x3 and negative examples x4, x5. So how we are going to specify that Wilson space here? S indicated. So x1 union, x2 union, x3, and for negative training example x4, the negation of x4 union x5. Okay, negation, that indicates negative. Positive means simple conjunction union we have taken. So negative means negation of x4 union x5, because x4 and x5 instances are negative training instances. Okay, so that is the thing. So an unbiased learner is, so we are having a candidate elimination algorithm, same using hypothesis space H. This is the inductive system. Here we are giving input as training examples and new instances, getting that thing as classification of new instance or don't know. So some situation that is occurring, don't know, previous one itself. Okay, but if we'll go for equivalent deductive system, that is inductive bias system. So same training examples is given input, and along with that new instance, along with that the assertion H contain the target concept, that also it will be given as an input. So that is the using that inductive bias it can be made. Then the theorem prover, that corresponding theorem proved means same output we are going to get. But what is the difference between inductive system and equivalent deductive system is this performance, that is efficiency will be more. Okay, will give the accuracy is more on the equivalent deductive system compared to inductive system. So there is a major difference between inductive and equivalent deductive system. Okay, performance wise only we can compare. Okay, so that's all about this first module. So the first module we have studied finders and candidate elimination. The next module completely based on decision tree learning. Okay, so that this is concept learning, next is decision tree learning. So that we are going to see in the second module. Thank you.